Now we are going to deal with the origin of solar system. There are two different theories for the origin of the solar system. The first one is going to be the evolutionary theory. So it deals about the gradual evolution. And the second one is catastrophic theory. These two are related to evolution or the origin of our solar system. Right. Now, evolutionary theory. Both the sun and the planets evolved together from a single cloud of gas. This cloud of gas is called as the stellar nebula. So we say both together, both, and then we have together. Both the sun and the planets, right? So both the sun, and then we have the both the sun and the planets together. This is from a single cloud of gas. Sun and the planets age is going to be same for the sun, and then we have the planets, right? Now we have two different types of theories. First is the gaseous theory, gaseous hypothesis, and this is by Immanuel Kant, and the nebular hypothesis, right? Now, when we are going for the catastrophic theory, the star, that is the sun, has already existed, and some catastrophic event happened. Because of this, some parts of the sun came out as planets, right? Sun already existed. Some catastrophe happened. So, due to this catastrophe, planets came out of the sun. Now we have two different types of the theories. Those theories are evolution. Through evolution, both are evolving together. Together is what we call it as evolution. Evolutionary theory, right? The second one is going to be the catastrophic theory. So evolutionary theory and catastrophic theory. Evolutionary theory is when both the sun and the planets evolve together from a single cloud. There is a single cloud of gas. Therefore, we say the sun and the planets are having same age. In the catastrophic theory, sun already existed, but due to some catastrophic event, some part of the sun in the form of planets they came out. Sun is older than planets. Planetesimal theory, tidal hypothesis. So here for the catastrophic theory we have the planetesimal and tidal hypothesis. So we have the planetesimal and then we have the tidal hypothesis. So for the sun we have two types of the theory, and those are called as the planetesimal, and then we have the tidal hypothesis theories. Now for the evolutionary theory we have gaseous hypothesis as well as nebular hypothesis. For the evolutionary we have the gaseous hypothesis and nebular hypothesis. For the catastrophe we have planetesimal, tidal, planets plus tidal, gaseous, nebular, planet, and then we have the tidal. Gas is what nebula also, right? Planet and then the tides. Now gaseous hypothesis. There was a gaseous cloud. It had cold and hard particles. Under the influence of gravity caused attraction as well as the collision which generated the heat, and it started to spin. Now how does a cloud spin is what mentioned in the gaseous hypothesis, right? A cloud is going to spin in the gaseous hypothesis. Now we have a cloud, and this cloud, gaseous cloud, it has cold and hard. So it is having cold as well as hard particles. Right. Now under the influence of gravity first, it causes attraction. Gravity causes attraction. Right. Now it again causes the collision, because of which the heat is being released and it starts spinning. Collision heat spins. So collision heat spins. Then the nebula is the kind of a structure we have protostar, right? Gaseous compound ejected some ring of materials. Then here, before it is forming a star, there is a ejection, right? Ejection of ring of matter. Now, because of this ejection is because of centrifugal force. When it condenses, it is due to centripetal force. But when the ejected ring of matter, it is because of centrifugal force, is because of the ejected ring of matter. Is because of the centrifugal force. And then we have concentrated compactly. It has concentrated very compactly, right? Therefore, it become planet. The central mass is the sun. So, gaseous hypothesis is very simple, right? In the gaseous hypothesis, initially there is a gaseous cloud. What is present initially? A cloud is present. This cloud is having cold. Initially it is cold and hard. That is why it is not spinning initially. Due to the influence of the gravity, it just collided. Right, colloids. And because of the collision, heat is generated. This heat is responsible for spinning of the cloud. Due to spinning, what happened? Nebula, right? Spinning and nebula kind of structure, but here we have ejection, the form of rings of matter. The ejection is in the form of the ring, right? Now the ejection in the form of the ring, it is due to the centrifugal forces. The ejection is due to the centrifugal forces. Now this centrifugal forces led to the concentrated compact of planet, and we also have the star. The central mass is the sun. Now let us look into the gaseous hypothesis even more clearly. Propose that the material of the solar system condensed into the sun and simultaneously there are planets originated as isolated mass of the material from a single cloud of gas, that is both sun and the planets are same age. This is nothing but the evolutionary theory, right? Evolutionary theory, explanation for the evolutionary theory. Now what is gaseous hypothesis? Gaseous hypothesis is by the Immanuel Kant. So we have to remember that the gaseous hypothesis is by Immanuel Kant, has proposed the gaseous hypothesis. There was a cold and hard particles which collided with each other due to the gravitational attraction, releasing heat and gradually forming rotating nebula as a kind of a structure. From this structure, rings of matters were thrown off due to centrifugal force. This matter cooled down to form the planets. Then we have the nebular hypothesis. Gaseous hypothesis is Immanuel Kant. Nebular hypothesis is by Laplace. So we have the nebular hypothesis is by the Laplace. The gaseous hypothesis is by the Immanuel Kant, and then the nebular hypothesis is by the Laplace. Most widely accepted is the nebular hypothesis by Laplace. gaseous hypothesis is by Immanuel Kant. It is similar to the gaseous hypothesis, but it spoke more about the process than the origin. The rotating gaseous cloud, the nebula, is already present. It started to contract and the temperature is decreasing. Contraction in the size, which led to spinning. It started cooling. They are telling that initially a nebula was present, and this nebula started to contract because of decreasing in the temperature, right? Contracting in the size. The nebula started to spin faster. Because of the spin, the temperature is increased, and it became a flat disk ring matter ejected because of centrifugal force. It is a it is nothing but a little altered process of gaseous hypothesis. That is why the name is also gaseous and nebula. In the gaseous hypothesis, we have the gases in the first, and then because of collision, the temperature is increasing. Right. In the nebular hypothesis, we have the nebula. The nebula is contracting and the temperature is decreasing. The nebula is contracting and the temperature is decreasing over here, right? Now when it is contracting, it is subjected to collision, and because of the collision it starts to spin. The nebula starts to spin and it forms a disk. It is forming a disk, more flat disk, where ring matter is ejected. So we call it as the ejection matter is the ring matter ejected. Ring matter is being ejected due to the centrifugal force compacted the planets. A pre-existing nebula was there in a rotating state which gradually cooled down. Because of the cooling, nebula shrank and reduced in the size. It led to more spinning and started to heat up, which gradually led to the formation of a flat disk. So we have a flat disk over here. Ring of the matter, it got separated from the flat disk due to centrifugal force, which got condensed to form the planets. Now catastrophe is because something big happened, right? Catastrophe is because both both forms simultaneously is evolutionary. Catastrophe is nothing but the sun was already present, and due to some events a part of the sun came out as planets. This is what we have. The catastrophe is having two different types of theories, right? Planetesimal theory and then tidal hypothesis. Planetesimal and tidal hypothesis. The evolutionary is having the gaseous hypothesis and nebular hypothesis, whereas the catastrophe is having planetesimal theory and tidal hypothesis, right? Now, it is also called as binary star theory because for catastrophe, let's say this is sun. Another big star is coming and dashing with the sun. This is mostly propounded theory, right? So therefore, we call the catastrophic theory as also the binary two-star theory. Binary two-star theory. Binary star theory. Now this planetesimal theory, and then we also have another theory, right? Tidal hypothesis, right? Planetesimal theory is by Chamberlain and Moulton. So planetesimal theory is by Chamberlain, and then we have Moulton. So the planetesimal theory is by the Chamberlain, and then we have Moulton. Gaseous hypothesis is by Immanuel Kant, whereas we have the nebular hypothesis is by Laplace, right? Now this planetesimal theory is by Chamberlain and Moulton. Chamberlain and Moulton together they gave the planetesimal theory. In the planetesimal theory by Chamberlain and Moulton, a protostar was accompanied by a companion star. Protostar, companion star, right? As the companion star came near to the protostar, gravitational pull led to ejection of small particles from the protostar. The ejected matter gradually became planets, right? Two stars are there. One is protostar and other is companion star. It just came close together. Close. The companion star comes near to the protostar. Companion star. So they say that the companion star has come near to the protostar. The companion star has come near to the protostar, right? This has led to the gravitational pull. Therefore, there is a gravitational pull between them, right? So, we will be having the gravitational pull. Gravitational pull between them. Protostar and a companion star. Companion star is the one which came near to the protostar, right? The companion star has come near to the protostar and it has caused an attraction. Due to gravitational pull, there was an ejection. This theory is proposed by planetesimal theory is proposed by Chamberlain and Moulton. It became planets that started revolving around the sun. Now this that is why we call it as a binary star theory in the catastrophic theories. Now tidal theory is by Jeans and Jeffries. Jeans and Jeffries. Right. So we'll be having the tidal theory. The tidal theory is by the Jeans and Jeffries. Chamberlain and Moulton is planetesimal theory. We go back, nebular hypothesis is by Laplace. Even more further, we go for the gaseous hypothesis is by Immanuel Kant. Now we have the tidal theory, right? The tidal theory is by Jeans and Jeffreys. It proposed a very big intruding star came near to the sun. Gravitational pull led to the ejection of tidal materials which formed planets over a period of time. A limitation. By the law of physics, matter ejected from the sun becomes expanding, it does not compact. If a matter is ejected, that matter is expands. It is not compacting. To form planets is the law of physics. The lifespan of the sun is 10 billion years. Already there are 4.8 billion years over. Further by 5 billion years, we will see red giant when we have the planetary nebula, right? Still 91% of the hydrogen is present. One layer of the sun alone is visible. The visible layer is what we call it as the chromosphere. Is the visible layer of the sun. The inner layer is the core, radiative zone, radiation, convection. Then we have photosphere, chromosphere, corona. Atmosphere of the sun is chromosphere. The outer layer is photosphere. The atmosphere is what we call it as the chromosphere. Now, radiation is that the energy comes from a source and it travels through the space. Innermost part of the sun is what we call it as the core. Now, nuclear fusion reaction is happening. Hydrogen fuses together to form helium plus energy in the nuclear fusion reaction, which is taking place in the core. For nuclear fusion to take place, the temperature is 15 million degrees Celsius. Is the temperature for nuclear fusion to take place. Radiative zone, right? Energy moves. It does not require any matter. The method through which heat is transferred to upper layer in terms of radiation, right? Heat is transferred in terms of radiation. Convection is energy gets assimilated with the matter and moves along with the matter. Atmospheric is photosphere is light and a sphere. Sorry, the only visible layer is photosphere, not chromosphere. Chromosphere is the atmosphere, right? Now here The layer which we can see on the surface is a visible layer which emits visible light. It is the brightest layer of the sun. It is having 5500 degrees Celsius, whereas 2 million degrees Celsius is the temperature of the corona. It suddenly increases from 5000 to 2 million. 5000 at the chromosphere, but 2 million at the corona. Corona temperature is 2 million degrees Celsius, right? Photosphere is having a temperature of 5500 degrees Celsius, whereas we have the corona is having 2 million degrees Celsius for the corona. The chromo means it is a color, it is having bright red color, it is not visible in the normal sphere, even it is above the photosphere, because photosphere is so bright it blocks the chromosphere. And then we have the corona. Chromosphere is red, bright red, whereas the photosphere is in the visible light, emission in the red color, right? When the when the during the solar eclipse, chromosphere and corona is visible during the solar eclipse, where the sun is blocked by the moon. So we have the chromosphere and corona is visible. The rise temperature from photosphere to chromosphere. Photosphere 5500 degrees Celsius to chromosphere 2 million degrees Celsius. Sorry, corona is 2 million degrees Celsius is unknown. Now we are again just going through the sun, right? The core is the innermost layer of the sun, where the temperature is 15 million degrees Celsius. Nuclear fusion reaction taken place. Highest temperature. Radiation is energy from the core is carried outward by radiation through this zone. Convection zone, where the heat through the convection currents. Atmospheric layer is the photosphere, so convection currents, right? Photosphere, the lowest layer of the sun's atmosphere. The visible light originates from here. The temperature is 5500 degrees Celsius. It is the brightest layer of the sun. Chromosphere is the second layer of the atmosphere, the intermediate zone which appears like a red rim during an eclipse. Corona is the uppermost layer which is visible only during the total solar eclipse. That too during the total solar eclipse, and it is during a solar eclipse only. It is hotter than photosphere with the temperature reaching to 2 million degrees Celsius. Solar flare. Suddenly there is an outburst of the energy from the sun. Right? Suddenly there is an outburst of energy from the sun. Yes, sudden outburst of energy from the sun is what we call it as the solar flare, because the entire interior of the sun is not a uniform gas concentration. Therefore we have sudden burst of energy. We say that sudden burst there is a sudden burst of energy, is what we call it as the solar flare. Is the sudden burst of energy. A sudden outburst of the solar flare with a storm of hot atoms having higher magnetic energy into the space. Sunspots, and then sunspots is having a cycle also, right? The magnetic energy is high over a dark spot. The temperature is less on the dark spots on the sun. The magnetic energy is high. At this spot, a magnetic energy is high. So here we be having that solar flare, right? Solar flare, and then another term is related to the sun is sunspot. What is a solar flare? Is the sudden outburst of energy. Energy is outbursted in the solar flare. So solar flare is nothing but the sudden outburst of energy. So a sudden outburst of energy is the solar flare. It's a sudden outburst of energy, and then the magnetic energy is high. Over a dark spot, the temperature is less. Solar maximum is when the sunspot of maximum, and solar minimum is when the sunspot of minimum. It is having continuous changes, moves in the form of a cycle. Solar maximum, solar minimum. It goes in the form of a cycle. Last solar maximum was in 2014 and the solar minimum was in 2019. At most, the period varies with a period of 11 years, right? Sunspots is the dark positions. These are in the photosphere. In the visible layer, right? In the visible layer, we are having dark portions in the visible layer. So dark portions in the visible layer with reduced temperature. The temperature is reduced, but strong magnetic field. Sudden outburst of energy is solar flare is the sudden outburst of the energy. Right. Now we have sunspots, dark position on the photosphere. So we have a dark position on the photosphere with reduced temperature but very strong magnetic activity. The temperature is reduced, but there is a very strong magnetic activity. Sunspots are there, right? Solar cycle or sunspot cycle. There is no sunspot of the sun surface or increased or decreased over a period of time. Increased is what we have solar maximum and decreased is solar minimum. The cycle varies, and there the temperature is 3800 degrees Celsius. It is having low temperature but high magnetic activity, right? The temperature is 3800 degrees Celsius. The normal temperature of photosphere is 5500 degrees Celsius. Now this is related to the sun.